Well, good morning again. We've said hello in the meet, and rather than try and fight through the notes, sharing a screen, which is always an epic disaster, I figured I would throw together a quick video. My apologies for the messy marker and the rush job on this whole thing, since we just got our notification last night that we were going remote. It is not that pretty, but we're going to roll with it anyways. Okay, so Pythagorean Theorem, finally. We're gonna do it. I know you've done it before, but we're gonna hit it again. What the heck is it? Well, it applies only to right triangles. So only works for right triangles. That's huge. Remember, with a right triangle, we've got two legs, and then that side opposite the right angle is called the hypotenuse. Generally speaking, we call this A, B, and C. And the Pythagorean theorem, A squared plus B squared equals C squared, or leg squared plus leg squared equals hypotenuse squared. Converse is also true. So if I gave you some random triangle and said, hey, is it a right triangle? You could just plug the numbers in. So you could be like, well, x squared plus y squared equals z squared. So yes, it's a right triangle. So leg squared plus leg squared equals hypotenuse squared. And if that relationship holds, but you don't know the measure of the angle, you can, genius. It is a right triangle for sure. So let's do a couple of examples. We will start by finding the value of x. So if I am plugging this into my formula, the most important thing is that C always represents the hypotenuse. That's this guy. The other two really don't matter. So x squared plus 24 squared equals 26 squared. This is when that list of perfect squares comes in handy, unless you have a calculator nearby. 24 squared is 576. 26 squared is 676. Get x squared by itself. And then finally, take the square root of both sides, and we get x equals 10. This is where we'll put the converse into play. So given three sides, determine whether the triangle is right. This would have to be the hypotenuse if it were a right triangle because it's the longest side. So basically, I'm asking myself, does 40 squared plus 96 squared equal 108 squared? And obviously these numbers are huge, so I'm going to need to grab my calculator. 96 squared, wrong button, is 9216. 108 squared is 11,664. 1600 plus 9216 is 10,816. Clearly those are not equal, so it is not a right triangle. All right, this one on the bottom, find the value of y. Leave your answer in simplest radical form. So process is the same. This would have to be C, it's opposite the right angle. So y squared plus 2 squared equals 12 squared. 2 squared is 4. 12 squared is 144. Subtract 4 from both sides. And then I take the square root. Square root of 140, I believe, has some perfect square factors in it. 4 goes into that. So I'm going to rewrite this as radical 4 times radical 35, which means y equals 2 radical 35. Generally speaking, if you are solving a straight up math problem, like here's a picture of a triangle, find the missing side, you want to leave your answer in simplest radical form. If you are solving a word problem, for example, you're calculating, I don't know, how much lumber you need to close in a fence or whatever, it's unlikely that you're going to walk into Home Depot or Lowe's and ask for, 2 radical 35 feet of lumber. they're going to look at you like you're an idiot. So if it's a word problem, you probably want to use your calculator, round to the nearest tenth or whatever. If it's a straight up math problem, simplest radical form. Okay, moving on. There are some things we call common Pythagorean triples. So Pythagorean triples meaning, be cool if this would autofocus. Pythagorean triples meaning numbers that work in the Pythagorean theorem. For example, 3, 4, 5 is a triple because 3 squared plus 4 squared does in fact equal 5 squared. So there's a common Pythagorean triple. Wow, the focus is great. 5, 12, 13 is another common Pythagorean triple. 8, 15, 17, a common triple. 7, 24, 25. There are others. These are probably the 4 most common, but what's pretty great about these, if you remember them, now you're not going to fall apart miserably if you don't remember them, because you can always plug numbers back into the Pythagorean theorem and solve it that way. But if you remember these triples, then you also know a whole lot more triples, because every multiple of a triple is also a triple. So for example, since 3, 4, 5 is a triple, I could multiply all those sides by, I don't know, pick a number, let's say 11. That means that 33, 44, 55, also a triple. And what that'll do for you, sometimes, if you see it right away, you'll be able to solve these real quick without showing a heck of a lot of work. So for this one, 15, 36, maybe I don't see the triple right away, and I'm going to substitute 15 squared plus 36 squared equals question mark squared. Or maybe I see that this is a 5, 12, 13 triple. 15 is 5 times 3. 36 is 12 times 3. So that means this side must be 13 times 3, or 39. Similarly, number 5, this is 7 times 2. This is 25 times 2. 7, 24, 25 is a triple, so this must be 24 times 2, or 48. Again, you can survive without knowing these triples just by plugging it into the Pythagorean theorem, but it's one of those, if you know it and you feel comfortable with it, it may make a few of these problems easier. All right, a little bit left. All right, so we already know that if c squared equals a squared plus b squared, the triangle is right. Now, we can also use this Pythagorean inequality. If c squared is less than a squared plus b squared, the triangle is acute. And if c squared is greater than a squared plus b squared, the triangle is obtuse. So that means if I give you a random set of sides, 10, 11, 13, and say, hey, what kind of triangle is it? I'm going to start with what would be the hypotenuse if it were a right triangle, so the longest side. And I'm going to ask myself the relationship between 13 squared and then 10 squared plus 11 squared. 13 squared is 169. 10 squared is 100. 11 squared is 121. So 169, 221, that is less. So a triangle with those 3 sides would be acute. For number 7, some of you may look at that and say, ooh, that's a 3, 4, 5 triple. 3 times 3, 4 times 3, 5 times 3. Automatically makes it a right triangle. You don't have to do any work. If you don't see that, you're asking yourself the relationship between 15 squared and then the sum of 9 squared and 12 squared. 15 squared is 225. 9 squared is 81. 12 squared is 144. 225, 225. Those are equal. So this is, in fact, a right triangle. Oh, sorry. Oops. Again, I need to pay attention. I've got 2 different screens going and the camera going. All right. It's your turn. So I'm going to try and show you this entire thing if I can. Basically, there are 7 or 8 problems here. This is your classwork. So if you want to pause the video and do it as you go, if you want to write them all down and then shut the video off and do it, that's fine too. So you've got these 3 to do. You've got these, try and sneak them all in there. Oh, not quite. 4 to do. Try and move the camera up a little bit. Yeah, it's just not working. So you've got these 4 to do. And then finally, you've got this 1 to do. And so the expectation would be the video, 10 and a half, 11 minutes. You've taken notes. At the end of your notes, I want you to do those 8 problems. And then I want you to upload as your assignment into Google Classroom photos of all of this. So your notes and these 8 problems, that is your assignment for the day. If you finish it before the meet ends, great, upload it, you're done, happy Thanksgiving. If you don't, then keep in mind that we have the optional afternoon session. Do it right after, I don't care when. As long as this gets uploaded today, you're good. Come back to the meet and say, hey, bye.